student. So today's topic is sets. Okay, now sets and relation will cover here. And in this one, actually direct will start. Uh, I think so. In this one, not very new thing in this one. Okay, now for you. So set, set will be represented by capital letters A, B, C, D. Okay, now whatever means set is a representation, and sets element, sets element are can be represented by a small letter in the curly braces. Okay, now A, B, C, D, E, F. Let's say these things. Okay, now and definition is very clear to you, I think so. A set is a well defined class or collection of objects or whatever you want to just collect. Okay, now those things should be defined actually. A set is described in the following two ways. Okay, now roster, tabular. Okay, now this is tabular format, and one is set builder format or rule. Like if I am saying that one set I am writing here, A equals to A E I O U. Okay, now so this is called a roster form. Okay, now in tabular form it is written in format of table. Let's say a same set I am writing A equals to X, such that X is vowel. Okay, now vowels of alpha of um, English letters. Okay, now okay, now so that one, it is nothing but you can say again, you can write A E I O U. Okay, now so meaning is what? Rule. It is given some rule here. Element will be represented in set builder method, and its a property will be defined here. Okay, now whatever the rule is there, that will be given to you. From this information you can collect all these X. Like one set I am writing here, you can see A is equal to, if I am saying that X, such that X is X is uh, all natural numbers which are divisible by 2 and less than 40.5, let's say. Okay, now so in this one, what you have to collect all those natural numbers which are divisible by 2 but less than 40.5. That is 2, 4, 6, 8. Okay, now 10 dot dot up to 40. These are the numbers. Okay, now number of element in set is represented by n of a. Okay, now n of a is represented by number of element. Let's say in this one you have to count. Okay, so you can see that here total number of element. Okay, now 20 number of elements are here. Okay, now 20 number of elements. Okay, so in this one I think so no any problem to you all. Number of element, let's say I am writing A equals to 1 2 3. The number of element will be what? Number of element will be 3. Okay, now only A union B, only set is written in this format or in this format, not like that. Maybe your set may be in this way also. In these set you can see elements are written in discrete format. Discrete means 1, then 2, then 3, then 5, like that. Okay, now if I am writing a set, let's say number line I am taking here, number line. Okay, now if number line I am taking here, and I am saying from you have to take number greater than 2 and less than 5. Okay, now greater than 2, less than 5. So meaning what? You are taking A equals to X, such that X belongs to X greater than 2 and less than 5. Okay, now X belongs to real number, you are saying any real number you can take, but greater than 2, less than 5 means you don't have to take 2, correct or not, and you don't have to take 5, but between these any number you can take, correct or not. Any number you can take, but you don't have to take uh, either 2 or 5. Between these any number you can take. Okay, now meaning I think so it is clear to you. So this type set is written as open interval 2 comma 5 means in this one, in this set, neither 2 is there nor 5, but between all numbers are there between 2 and 5. Similarly, if I am writing a equals to let's say x, such that x is greater or equal to 2, less or equal to 5, x belongs to real number. Okay na. So what is the meaning of all numbers from 2 to up to 5? Okay na. So close interval 2 to 5, close interval 2 to 5 means now this time you are taking this number also. Okay na, this to this number also, 5 also you are taking this time. Okay, similarly if a I am writing a equals to x, so that x is greater or equal to 2, less than 5, x belongs to R. What is the meaning of this one? X greater or equal to x, you can take now this time 2, but less than 5 means at 5 open interval, you don't have to take 5, but less than 5 number. Okay now, a equals to, if I am taking x, such that x is greater or equal to 2, greater than 2, less or equal to 5, x belongs to R. What is the meaning of this one? All real number greater than 2 means you don't have to take after 2 any number you can take. Okay na. But less or equal to 5 means r equal to means 5 you can take. Okay, so these are called this is open interval, this is half open half close, half close half open, and this is close interval. Okay na. So these things I think so it is very clear to you now. If two sets are given, then a union b is there. Okay na. A union b is defined what? A union b is x such that x belongs to a or x belongs to b, x belongs to b. Okay na. This definition I think so clear to you all. Okay, in this definition no any problem. What is the meaning? Let's say a I am taking a set 1 2 3. Okay na. B I am taking a set 2 5 7. Okay na. Then a union b will be what? Then a union b will be, it is saying that set of all element either in a or in b. Or means what? You have to write set of both elements. Okay now, you know in set same element you don't have to write two times. Okay now, only one times you have to write. So one in first set. Okay, two in first set and second set. Okay, that is also okay. Three in first set. Okay, three. Five in only second set. It is saying that or means you can write element of b or element of a. So 5 will be also there, 7 will be also there. Okay now, so number of element if I am talking about n a union b will be what? That is nothing but 5 number of elements we are getting here. Okay now, so a union b I think so clear here. Now if I'm saying to you by Venn diagram how it will look like. Okay now, so let's see by Venn diagram. Okay, so two sets I am taking here. This is let's say a and this is let's say b. In a 1 2 3 because 2 in both, and in b 2 5 7. Okay now, so whatever the element which are in both, that is called in intersection. Okay now, in the intersection the remaining element only in set a, and here 1 and 3 only in set a, and here only in set b. So actually a union b is total. Okay now, total is a union b. So because either in a or in b means only in a set, only in b, and what, and those element also you have to take which are in a and b both. Okay now, and means common, or means union. Okay now, so directly from here can I say that number of element in a union b equals to number of element you are saying in a plus number of element you are saying in b. Correct or not? So in this one actually what is happening, this common element 2, is counted two times. You can see, because in this one number of element 3, in this one number of element 3. Okay now, so 3 3 6, but total a union b having 5 elements means this 2 is counted two times. This 2 is common element. So what I have to do, I have to subtract from this one what? Minus intersection element one time I have to subtract, because that one counted two times. So one time subtract, minus number of element in a intersection b is which are in both. Intersection means which are in both 1. That is nothing but 3 3 6 1 minus 1 5. Okay now, so a union b formula is this one, keep in mind. Okay now, a union b formula, n of a union b equals to what? n of A union B, number of element in A union B equals to nothing but number of element in A plus number of element in B minus number of element in A intersection B. Okay, intersection I defined here, so no problem. I think so. Intersection means what? If I am writing definition, A intersection B meaning what? Okay, now mathematically definition. Once I am writing here, A intersection B is nothing but X such that X belongs to A and X belongs to B, means those element which are belonging in both. So from here, if I want to write A intersection B, the only two you will have. Okay now, so in Venn diagram also you can see 2 is only in intersection in both. Okay, so this formula will work for both union intersection. Let's say union given. Okay now, let's say union given, then intersection type thing you can find, and A B given and intersection given, then union type thing you can find if sets are given. Okay now, so I hope so this is clear. Intersection union. Okay now and this one subsets are defined. Subsets. Okay now, subsets are defined. A is any set and B is another set. Okay now, if all element of set A are in set B, then set A is called subset of set B. Okay, so it is represented by A is subset of B. Okay, now how it can be written in format of set X such that X belongs to A. Okay na, comma X belongs to and X belongs to B, you can say. Okay na, no, we are writing A is subset of B, means in this one you are writing all the element of A actually na. Okay, so no need to write in that format. A is subset of B means what? A is subset of B means what? If I am taking X belongs to A is subset of B, what is the meaning of this one? This is meaning that X belongs to A, all the element of set A are in set B, means set A is called subset of. So X belongs to A. If I am saying X belongs to A, this implies X belongs to B automatic, because you are saying that if X belongs to A, then X belongs to B. Okay, now, so this is the meaning we are getting from here. Okay, so this is subset. Now let's say I am taking A is a set 1 2 3. Okay, now, so number of subsets will be what? Subsets. You can say, sir, 1 is one subset because all element of this set is in this set. 1 2 3. Okay, I'll say this one also 1 2. You'll say that 2 3 also. You will say, sir, 1 2 3 also. This is a set which is having all element of this one, means both set are equal, but means equal set are subset. And 5 is an empty set which is subset of all sets. So 1 2 3 4 5 6. How many we are getting? 1 2 2 3 3 1 also, no, 1 3 also. Okay na, so 1 2 3 4 5 6 7 8. Okay na, 8. So actually one formula is there, the number of subsets of set A equals to 2 power n, where n is number of elements in set A. Okay na? I hope so it is clear to you all. So in this one I told you set and close interval, open interval, okay now, intersection, union and subset. And this is again one formula we are having here, that number of subset in set A equals to 2 power n. In that one including what? Including 5 is including here. Okay now, 5 is we are including here. Now difference of two sets, okay now, Difference means it is represented at, let's say, a, if I am saying um, a and b are two set, okay now, then a minus b represent difference from a, okay now, from a of b, okay now. So it is meaning what, you are subtracting all element of b from a, so you can say it will be what, x belongs to a minus b, means you, let's say I'm taking first example, okay now, 1 2 3 4 5 I am taking, b I am taking 2 3 6 7, okay now. So a minus b, what I'll write, you are saying that just subtract the element of what, element of b from a, so whatever the remaining element will be, that one is the answer. A minus b means all the element, which are in a but not in b, means subtract the element, then 1 in not b, then 1 will be here, no problem. 2 is here, then 2 is removed from here. 3 is here in both, so 3 is removed, okay now. 4 is not there, 4 will be remaining, and 5 will be remaining. You will say 6 and 7 what, because these are not in this one, then you cannot remove, okay now. From a whatever the remaining element will be there, means a minus b is nothing but um, all elements, which set of all elements which are in a but not in b. Then you can see here 1 4 5 actually are in a but not in b. This is the answer. So how I'll write in mathematical format, okay now. A minus b, you are saying set of all elements which are in a but not in b, means x belongs to a, okay now. X is such that x belongs to a but x not belongs to b. This is the definition of a minus b. Similarly, b minus a will be what, let's say here I am saying to you find b minus a, means subtract those elements which are in a, okay now. Means the total will be what, set of all element of b which are which are in b but not in a, okay now. So which are in b but not in a, that is only 6 comma 7, otherwise all element are in, okay. So meaning is 2 subtracted, 3 subtracted, remaining element whatever is there, that we have to write, okay now. Set of what, again I am writing set of all elements which are in b but not in a, okay now. So this one done here, I hope so in this one no any problem, okay. So a minus b is also done. Now in modulus, one thing I am telling you, let's say you are writing here modulus, modulus breaking, modulus x is equal to what, modulus x is equal to x if x is greater or equal to 0, minus x if x is less than 0 or less or equal to 0 also work, no problem, okay now. So this definition is modulus x, breaking of modulus x, okay now. Let's say I am writing here that modulus x is less than 3. So few example I am taking first. Let's say I am saying modulus of 3 will be what, then 3 is positive, x greater or equal to 0, then 3 answer direct. Minus 3 will be what, you are saying that minus 3 is negative number, so minus of x, so minus 3, that is positive. Meaning is what, this is called absolute value, okay now, absolute value of x, okay now, that is modulus x. So meaning is whatever number you are taking, you are going to take, answer will be positive, okay now, either positive or negative. So here also you will say, okay, what number you can take from real line, so that answer is always modulus x is less than 3. So x, you will take whatever x you are putting here, that answer should be less than 3. You tell me, if I am taking these number from minus 3, okay now, greater than minus 3 to less than 3, any number I am taking, like here minus, let's say minus 2.99 I am taking. So here if I am putting minus 2.99, okay now, then this modulus will be what, only 2.99 absolute value, and that is less than 3, correct or not. So whenever you are writing modulus x is less than a, meaning what, from greater than minus a2 plus any number you can take. Here you can take 0, 0 is less than 3, 2.99, 2.99 up to 2.99 is less than 3, correct or not? So we can make a rule what, that if it is written modulus x less than a means what, x is greater than minus a to less than a. If here less or equal, modulus x is less or equal to a, then this one you will get what, x is greater or equal to minus a to less or equal to a. Okay now, I hope so this is clear to you all. One more example I am taking, like if it is written like this one, let's say modulus x, okay na, is greater or equal to 3, then what? You will say that okay, in real number you have to take only those x so that modulus of that one is greater or equal to 3, greater or equal to 3. Let's say I am taking greater only, okay na, let's say I am taking greater only, then you can say sir, after minus 3, okay na, before minus 3 you can take any number, like I'll say okay minus 3.00001, yes, modulus of this one is greater than 3, means x from here, x belongs to from where to where, minus infinity to this negative minus 3 union what, union 3 to, after 3 any number you can take, then modulus will satisfy 3 to infinity. Okay, so this is the answer. So if I am making the result, actually in this one nothing you have to remember, just see the number line, x is greater than a. If I am writing, this implies what, x belongs to minus infinity to minus a union a to infinity. This is the answer. Okay now, and a should be actually, a should be, one second, a, okay, so what I was telling in this one actually, that a let's say I am taking one example, it should be actually greater than 0 now, otherwise it is like if I am saying no like if I am saying modulus x, okay now, is less than minus 2, one example in this I am taking. So modulus x is less than minus 2, is it possible that modulus x is less than minus 2? Modulus x is always positive quantity, correct or not? So from here no any solution you will have. Okay now, let's say I am writing modulus x is greater than minus 2, okay now. So okay, greater than minus 2, okay, but its value you know always positive, it's a value always positive. So how it will look like, that greater than minus 2 type thing, it is not making very good sense. Okay now, so it will be always, you know, it will be written here always some positive number. Okay now, like if I am saying this one, then what is the meaning of this one, the modulus x is greater than minus 2, modulus x will be always greater than what, positive number. Okay now, greater or equal to 0, that is always, it modulus x will be 0 only if x is 0. Okay now, 0 if only when, if x equals to 0. Modulus x is always greater than 0 if x is not equal to 0. Okay now, so this meaning I hope so it is clear to you. Okay now, remaining one we'll see.